All right, so last day, whatever it was, Friday? Did we teach Friday? I think so. So we started this. That's why this is 7.4b, because the other one was 7.4a. It's special right triangles. Do you remember what the first special right triangle was? Or not yesterday, but Friday? Was it? 45, 45, 90, right. We're going to do 30, 60, 90 today. All right, so Friday we did a 45. Let's write that a little bit better. 45, 45, 90 triangle. So what was that? Let's review it. I've had a weekend, so I'm sure you haven't spent your weekend reviewing 45, 45, 90 triangles. So we'll review it right now. So here we go. That's 45 degrees, and that's 45 degrees. If these two angles are 45 degrees, it also means that this side is equal to this side. Even if I didn't tell you that they were 45 degrees, if I told you that these two sides are equal to each other, you should automatically be able to figure out that these angles are 45 degrees. Sincere, in case you haven't noticed, we've started. All right.
Shalom Davis, Grace Fleming, Anaya Freeman, Logan Hill, Judith Johnson, Austin Saraka, Wayne Robinson, and David Morrison. Thank you.
Okay, here are the legs, and they're both the same. All right, on a 45-45, both of the legs are exactly the same. All right, so if I told you that this leg was equal to 5, automatically, if that's a 45-45-90 triangle, what is this leg? It's 5, okay? So that's pretty easy, right? If they tell you one leg, finding the other one's super easy. No math involved. Just look at it, write it down. Don't have to show your work, all right? You just write it down. But the hypotenuse, we went through why the hypotenuse was what it was. We're not going to do that. I'm just going to show you what it is. And here's our little formula for this. The hypotenuse equals the square root of 2 times one of the legs. So let's just use the 5 since I put a 5 right here. What if I asked you to find the hypotenuse? And it could be any letter. Oops, I don't want to get rid of the side. Let's just get rid of the words or the letters. There we go. All right, so let's call it C. Make it easy, A, B, and C. So if I wanted to solve for C, what would I do? It's almost as easy as just saying, well, if this side is 5, then this side is 5. All right, it's almost that easy. All right, but we don't know what it is, so what is it? It's the square root of 2 times one of the legs. What are the legs? 5. Now, you could write it like this, but that's not how we write it. When I have a square root and a whole number and they're being multiplied together, what's a better way to write this, do you think? Put the 5 out in front, okay? So if you got a whole number, an integer, being multiplied by a square root, then you put the whole number first, and then the square root next. This is the way that you should write your answer. And that's your answer. You don't have to put it into a calculator to get a decimal. Everybody understand that? All right, now you could, but you don't have to. And if I don't ask you to do it, I would not do it. I would not put it into a calculator. Now, if I said, solve for C and round your answer to the nearest tenth, what does that mean you should do? What if I told you to take the answer and round it to the nearest tenth? What should you do with this right here? Put it where? In a calculator, that's right. Okay? I would put it into a calculator and then come up with a decimal and round it to the nearest tenth. If I don't tell you one way or the other, just keep it like that, circle it. I think on that worksheet, there were a couple problems where it says, write your answer as an exact answer. This right here is an exact answer. Okay, so if I ask you to write it as an exact answer, you would leave it like this. You would definitely not put it into a calculator. If I said, round your answer to the nearest tenth, then you would put it into a calculator. So how do you do that? Good question. You need to know how to use your calculator. Here's what I would do first. Here, I'm going to write the buttons down. You could do the 5 first, I guess, but I would do the square root of 2 first. Everybody watch this. there's a button on your calculator that's got a square root. It might say mine just says square root. Doesn't have an X on there. All right, you got a button that just says square root. So you're not going to hit the square root button first. What you're going to do is hit the 2 first. Everybody see this? This is your calculator. Hit the 2 first, then you hit the square root, and then that gives you some number, 1.4142, blah, 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 blah. But then, so you hit 2, you hit square root, and then what you do is you take that number and you multiply it. All right, you got a multiply sign on your calculator, and then you multiply it by what? By 5, and then you hit the equal sign, and then that should give you your answer. Times 5 equals 7.07, blah, blah, blah. If I ask you to round it to the nearest tenth, round to the nearest tenth, which decimal place is the nearest tenth? It's the first one. That's right. It's this one right here. So what does that 7 do? If you're going to round it, it bumps it up to a 1. Good. Okay, if that's 5 or bigger after that first decimal place, then that bumps that up just by 1. And then, so really your answer, and I'm going to put a squiggly equals. Why do I put a squiggly equals? It's approximately equal to what? 7.1. All right? So an exact answer would look like this. An approximation, let's write that down. An approximation would look like this. All right? I think, I'm almost positive, not 100% positive, but I'm like 99% positive that on a quiz or a test, I don't say one way or the other. I do not say round it to the nearest tenth. I don't say write it as an exact answer. So if you were to write this answer, I would write it just like this and leave it alone and don't worry about it. Everybody got that? Okay. Now, let's do one more example, then we'll get to the next special triangle. Because this is all old stuff. Well, it's not that old. It's from Friday. All right, today's Monday. But it's stuff that we've already done before, let's put it that way. All right, let's do this. Now, what if I gave you, let's get rid of all this mess. What if I gave you the hypotenuse and not the leg? So what if I gave this to you as, I don't know, 3 square root of 2? All right, and I gave you this, but I asked you to solve, let's call it x. If I asked you to solve for this x right here and this right here, why did I make them the same letter? Why didn't I make it an a and a b or an x and a y? Because they're both the same, exactly right. Okay, so what if I asked you to solve for x? Solve for x. What would you do? You wouldn't multiply by the square root of 2, would you? You would divide by the square root of 2. Exactly right. Okay, so let's write it down though. The hypotenuse, I'm going to write this down, times one of the legs. All right, so there's my little formula. That's something that you should have memorized. If you don't have it memorized, do it now because you're going to have it memorized. Right? You got to know this relationship, that the hypotenuse is the square root of 2 times one of the legs. So what do? We just plug the stuff in we know. Do I know the hypotenuse to this? Yeah, what is it? How do we say this? We've said this a bunch of times. 3 times the square root of 2. Or you could just say 3 square root of 2 if you wanted to. It's the square root of 2. It's not to a certain power. Okay, it's 3 times the square root of 2. Everybody hear me on that? If you need to, write it down. Put 3, write the words down. 3 times the square root. You don't have to do it every time, but do it once. Then you can go back to it and look. Of 2. So this is how we say it right there. I'll put it in quotation marks. 3 times the square root of 2. Everybody got that? That's what this is right here. All right, that's the hypotenuse equals what? Let's finish up the rest of this formula. Well, I got a square root of 2 here times the leg. What's my leg in this situation? It's just x, so I'll put an x right there. What do I got to do? I got to solve for the leg. Solve for x, correct? So let's do that. Let's get x by itself. Well, what's going on with that x? What's next to that x? A square root of 2. How do I get rid of a square root of 2? If it's being multiplied, I divide it by the square root of 2. Come over here and do what? Divide by the square root of 2. Look what happens. That cancels. I'm left with x. What happens here? They cancel. What am I left with? 3. So 3 is my answer. And it should make sense. Would you agree? Because if this side was 3, how would I find the hypotenuse? I would multiply this by the square root of 2, wouldn't I? To get this. Everybody see that? All right, so if they give you the hypotenuse, how do you find the leg? You do the opposite of multiplying, which is divide. So if they give it to you as 3 square root of 2, it makes it kind of easy. Where it gets a little bit tougher is when they give you that hypotenuse as just a whole number. So what if they said the hypotenuse was 7? Everybody watching? All right, this is review, but I think everybody needs to see this. We're taking a quiz on this week, all right? And I already got people with their heads down. Just doesn't make any sense. I'm going to see you struggling on the quiz, and I'm just going to think back to this time right now where your head is on the desk, your eyes are closed, and you're not paying attention. Or you're talking to your friends, or you're not taking notes. All these things pop back into my head. Do they pop back into your head when you're taking a quiz and you're like, oh, crap, I don't know how to do anything on here? Does your mind ever go back to the time where I first taught this or when we reviewed for it and you weren't paying attention? It should, all right? If it does, then you probably will start paying attention again if you do poorly on the quiz. All right, enough of that. Let's do this problem. I'm still going to use this same formula over here, but the math is a little different. But for you guys, I'm going to let you keep it a way that for other classes I would not let you keep it. All right, because I just want you to know that you divide by the square root of 2. That's all. So what is the hypotenuse here? It's 7. The hypotenuse is 7. That's your hypotenuse. This is not your hypotenuse. These are the legs. Equals the square root of 2 times one of the legs. What's either one of the legs? It's an x. How do I solve for x? I divide by square root of 2, just like I did earlier. Divide by square root of 2. Actually, you know what? I am going to make you simplify this. Now that I think about it, all right, I don't want to take it too easy on you. Those cancel. So x is equal to 7 divided by the square root of 2. What did we say? I think Friday might have been the first time I said this, but what did I say about having a square root in the denominator? You can't, okay? Yeah, it's not simplified, okay? It's not simplified. So if you wrote that and you circled it and that's your answer, I would mark it wrong and I would say, what? Simplify. So how in the world do I simplify that? No, not put it into a calculator. That is not simplifying it. I have to get rid of that square root of 2. I'm not going to go through the whole reasoning because I still got another thing to teach today. This is all review so far. But watch the lesson from Friday and I'll give an explanation of it. So what we're going to do is this. We're going to multiply the top and the bottom by the square root of 2. Remember doing this yesterday or Friday? So why did I do that? Well, I did that because multiplying it by itself is...
The following students are also Dr. Lawson, Katie Montrose, Cable Long, KJ Law, Mackenzie Tabor, Trent Montgomery, Justin Luna, India Long Peterson. Thank you.
All right, by multiplying this by itself, what it does, it gets rid of the square root. And that's my whole purpose. My whole purpose in doing this is so I don't have a square root in the bottom. All right? So what's the square root of 2 times the square root of 2? We talked about that a bunch Friday. It's just what? Very easily, it's just 2. It's not the square root of 2, it's just the whole number 2. So I multiply those together and I get a 2. I multiply the top and I get 7 times the square root of 2. Do these 2's cancel out? I got a 2 on the top, 2 on the bottom. No, they don't because this is not a 2. You're like, it sure looks like a 2, Mr. Hamrick. I've been doing numbers since I was a little kid. That sure looks like a 2. But it's under a square root. Square root of 2 is like 1.414 something. Okay? This is not a 2. So they don't cancel out. That right there is the answer to your legs. So that's 7 square root of 2 over 2. Okay? Same thing with this leg right here. That's also 7 square root of 2 over 2. It's a weird looking answer, but that's how you do it. All right? Go back, watch the other video. You don't have to watch the whole thing. Just watch the part where I talked about this, and you'll see the reasoning behind it. All right, that's enough review. That's more review than I planned on doing. Yes? Yeah, if this was an 8, let's say. Good question. Let's do that. Let's say this was not a 7, but that was an 8. Everybody watching? So if this was 8, so this would have been an 8 right there. So it'd be 8 square root of 2 over 2. Now you got a 2 on the bottom. It's a whole number 2 on the bottom and a whole number 8 on the top. So now you could simplify that. 2 goes into 2 how many times? Once. 2 goes into 8 how many times? 4. So what's your answer? 4 square root of 2. All right? That's a good question. I should have thought of that. All right, but if it doesn't cancel, you would just leave it like this. If it does cancel, if that was an 8 or anything even, right? If it was any even number, that 2 would go into it, and then you would write your answer like this. All right? Okay, good. Thanks for that, Zion. Let's talk about the next kind of triangle, and that's a 30, 60, 90 triangle. All right? Now, there's 2 things to know about a 30, 60, 90, but let's draw one. It may not be an exact 30, 60, 90, but it'll be close enough. So it'll look something like this. It's a right angle because it's the 90. Now you got a 30 and a 60. Which one do you think is the 30 and which one do you think is the 60? Yeah, the smaller one down here is the 30 degree, right? And then this one up here would be the what? The 60 degree. What must be true about all 3 of these numbers? Well, these 2 numbers right here, the 30 and the 60. They got to add up to 90, that's right, because there's 180 altogether, correct? All right, so there's 30, 60, 90. So notice, are both of the legs equal to each other this time like they were on the 45, 45, 90? No, definitely. This one's definitely shorter than this one down here on the bottom. This one is still the hypotenuse, no matter what. Why is this one still the hypotenuse? Because it's opposite the right angle. Good. So we call this the short leg, and we call this the long leg. All right? Put leg right here. I probably will not write down leg every single time. I'll say this is the short side or the short leg. This is the long side or the long leg. But which one on a right triangle is always the longest side? The hypotenuse is always the longest side. This is just a longer side, okay? You with me? This is the shortest one. That's a longer one, but that's the longest one. Got it? So it doesn't mean it's the longest side. It just means it's the longer what? Leg. It's the longer leg. All right? We got 2 things to know here. I'm just going to write them down. I'm not going to show you where they came from. I'm just going to write them down. Now, what's interesting about this is both of these relate to the short leg. All right, you'll see what I'm talking about in a second. So I'm going to draw a little arrow there, and this one also relates to the short leg. So they all have to do with the short leg. The hypotenuse is exactly twice as big as the short leg. So let's pick a number for the short leg. Give me some easy number. Let's go 3. Okay? So let's say that's 3. What's the hypotenuse then if the short leg is 3? It's 6. It's super easy. Okay? It's just twice as big as the short one. Everybody see that? All right? What if the short leg was 7? What's the hypotenuse? What if the short leg was 50? What's the hypotenuse? You got it. Everybody with me on that? Okay. It's almost, not quite. The longer leg, now here's a weird number. I'm not going to show you where it came from. I don't think you'll care anyway. All right? But this is kind of interesting that it's the square root of 3. You're like, where did that come from? Don't worry about it. If you look at the honors geometry, did we do that this year? I don't know. We might have. Either this year or last year, I went through why it's the square root of 3. So there is a reason for it. There's a specific reason. I'm just not going to go through it with you. But it's the square root of 3 times which one? Remember, they both relate to the short side. So it's times the what? Times the short side, or the short leg. Okay? Now, why the square root of 3? Like I said, there's a reason for it. But here's how you can remember it. 2 is the same thing as the square root of 4, isn't it? So the long leg, this long leg is just a little bit shorter than the hypotenuse. So would you agree that the square root of 3 is just a little bit smaller than the square root of 4? Yeah, it is. In fact, let's punch it in. Square root of 3 is about 1.7, all right? 1.7. So the hypotenuse is twice as big, 2 times as big. The long side is around what? 1.7 times as big. So it's just a little bit shorter than the hypotenuse. Everybody see that? That's how I can remember the square root of 3. Because 2 is the same thing as the square root of 4. Square root of 3 is just a little bit shorter than the square root of 4. So what's a little bit smaller than the square root of 4? The square root of 3 is a little bit smaller than the square root of 4. Agreed? So that's kind of how I can remember that square root of 3. So here's 2 things that's true on a 30, 60, 90 triangle. Okay? Both of these things you're going to have to memorize. So remember your 45, 45, 90. We just went over that. And you also have to remember the 30, 60, 90. Hypotenuse one's kind of easy, all right, because it's just 2 times the short side. The longer side's a little bit weirder, but you just have to remember the square root of 3. You have to remember it. All right, now I got more heads down than I had before. Guess it doesn't matter what I say. All right, I'm just going to keep going. It bothers me, but I'm going to keep going. Should bother you guys, the ones that have your heads down. I know you're hearing me. Should bother you more than it bothers me, because you're the one's going to fail the quiz. I'm not going to fail it. All right, you're the one's going to fail it. So let's do something about it. All right, and all you guys aren't writing anything down, are you? All right. I'll shut up. Let's keep going. Let's do an example, all right? Let's do this. I'll just rewrite. I'm going to copy that. I'm going to redraw a triangle. I'm going to make it look a little bit different because they all don't look like with the bottom just straight across, or that leg straight across. So let's see. I'm going to draw that. Okay, that's 90. That's probably about 60 right there. And that's not too bad. Oops. All right, so there's my right angle up there. So it looks a little different. All right, this angle right here is my 30-degree angle. This one is my 60-degree angle. All right, and let's do an easy one, because the example that I give, I did not pick the easiest example. I'm going to pick the very easiest example that I could do with this. Everybody with me? So let's say this is, 5. We'll make that 5. And I ask you to solve for x and y. Everybody good? All right, so to me, I think first of all, which side is the 5? Is it the short side? Is it the longer side? Is it the hypotenuse? Which one is the 5? It's the short side, okay? I probably should have drawn it a little shorter. Probably would have looked a little bit more to scale, but that's okay. How do I know it's the short side for sure, though? Very good. Perfect answer. It's across from the 30 degrees. 30 degrees is the smallest angle, so 5 is the smallest side. Everybody got that? Okay. So you know that that's the short side. You don't have to write it down, but in your head, you know it's the short side. What do you think is one of the easiest ones to find? The hypotenuse, because it's just what? It's just double it, right? So the hypotenuse, let's write it down again. The hypotenuse is twice the short side. So what's the hypotenuse? It's y. 2 times the short side. 2 times what? 5. So what's y? 10. All right? And there's your work. Okay, you can show work with this. I know you could have done that in your head. I get it. 2 times 5. Everybody could do that in their head. But I showed the work. I showed why it's 10. Okay? What about x? What side is x? It's the longer leg, right? It's the long leg. So we have a little formula, don't we? What's the long leg equal to? It's equal to, you should have it in your notes right in front of you. Square root of 3 times the what? Times the short. Good. To tell you the truth, this one possibly could be easier than this one because you actually had to do some multiplication here. You had to know what 2 times 5 is. What do you have to do here? Yeah, just put the number right next to it. It's the square root of 3 times what? Times 5. But we don't write it like that. How do we write it? 5 square root of 3. And that's what x is equal to. Would you agree? It's pretty simple. Yeah. It's not always going to be this simple. All right? But that's the easiest version that I could possibly give you on a 30, 60, 90 triangle. All right? Let's ramp it up a little bit. What if I give you the long... I tell you what. Let's do like the medium one. The one that's medium hard. First one, that was the easiest. Okay? In fact, I'm going to just erase this. We'll keep those right there. What if I gave you the hypotenuse? What if I said the hypotenuse was 12? Find the other two sides. So what do you think, Abdul? That's right. Instead of multiplying by 2 to get the hypotenuse, if I know the hypotenuse, how do I get this side right here? We'll call it x and y again. Then you divide by 2. Exactly right. Let me show you why you divide by 2. Because you put it into this formula. Hypotenuse is 12 equals 2 times the short side, or 2x. Everybody's watching? You divide by 2. There it is, right there. Do you see it? This is why you divide by 2. So x is what? 6. All right? So x is 6. Once I know the short side, the long side's kind of easy. All right? So the long side is y equals what? The square root of 3 times the short side. What's the short side? It's 6. I don't write it like this, though. How do I write it? 6 times the square root of 3. So there's both of those answers. That's really not that much more difficult than the first one. Would you agree? If they give you the hypotenuse. This is the one where it gets a little bit tougher. When they give you the what? The longer leg. Okay? So let's say that is 12 instead of the hypotenuse being 12. And you wanted to solve for x. We'll call this one z instead of y. Everybody with me? All right, so let's do this. I'm going to keep those formulas up there. And am I going to use this at all? No, because I don't know the hypotenuse and I don't know the short side, so there's no way I can use this one. But I am going to use this one. This has long and it's got short, so I'm going to solve for the short. So let's put some numbers in. What is the long side here? It's 12 equals the square root of 3 times the short side. What's the short side here? It'd be x. That's right. So how do I solve for x? Divide it by the square root of 3. Divide this by the square root of 3. There's a little problem on this. This is why I saved this to last, okay? Because this one's a little bit tougher, just because you got to simplify, okay? Getting the 12 over square root of 3 was kind of easy. But what do I do with that 12 square root of 3? Do I leave it? Do I circle it? That's it. So what am I going to multiply the bottom by to get rid of that square root? Yep, multiply it by itself, which is the square root of 3. And then do the same thing to the top. Let's see what we get. This looks like it's complicated at first glance, but when you actually start doing the problem, it's really not that difficult. Except for those who are not paying attention and doing other classwork, as I see. All right, square root of 3 times square root of 3 is? It's just a 3. Technically, it's square root of 9, isn't it? What's the square root of 9? It's 3. What do I do here? I just write 12 square root of 3. Do I circle that and leave it? You can simplify it, just like you said on that last one that we did with the 8. Remember that one? So look, you got a 12 and a 3 down here. So what happens? 3 goes into both of those. 3 goes into 3 once. 3 goes into 12 4 times. So finally, we're there. What's our answer? 4. It's not 44. Did you say 44? Okay. It's just a 4 what? Time. Not to the. Okay, it's a big difference. This is not an exponent. It's 4 what? Times the square root of 3. And that is your answer for the short side. That's x. That's 4 square root of 3. That was the toughest part that you're going to do on these kind of triangles. Right there. Okay, that's the hardest of all these things that we're going to do here. So if you can do this and you understand how it works, then the rest should be pretty easy. Exactly right. So here's the hypotenuse. What's the hypotenuse? It's twice the short side. Hypotenuse is z, so it's 2 times the short side. What's the short side? It's times 4 square root of 3. So what's the math? 2 times 4 is 8 square root of 3. So that's what z is equal to right there. It's 8 square root of 3. Make sense? Let's go backwards and see if it works. What if I was given the hypotenuse? I could find the short side. How would I find the short side? Divided by 2. What's 8 divided by 2? 4 square root of 3. Boom, right there, isn't it? Okay? So what if I was given the short side and I needed to find the long side? What would I do? I would go 4 square root of 3 times what? Times the square root of 3. Look, square root of 3 times square root of 3 is 3. 4 times 3 is 12. So it works, doesn't it? It's always good to see it go the other way, too. All right? Everything works out, you're good to go. Make sense? Yeah, we got some time. Let's do this. You remember doing an area? This whole chapter is supposed to be about area. Seems like we took a little break with the area stuff, right? With Pythagorean theorem and 45, 45, and 30, 60, 90 triangles. But we're going back to area, all right? So I want you to find the area of this triangle. Do you remember what the area of a triangle is? Of a triangle. Base, you're right, base times height, what? Divided by 2, okay? Or you could go 1/2 the base times the height. We'll do it like this, okay? So here's the triangle. Write this down. This is an equilateral triangle. In fact, I'll tell you what, I got a little thing over here where I can do. Let's make this a triangle. There's an equilateral triangle, and it's perfect. All right, so here's an equilateral triangle. What does that mean if it's equilateral? It means all three what? All three sides are equal. All right, and they tell you a couple things. Watch, they draw a perpendicular from here down to here. If it's perpendicular, what kind of angle do we have here? That's right. Now, you have to think a little bit. What do they tell you? Oh, they don't even tell you the side. I would tell you the side. So let's make up a number. Let's say it's, what number haven't we used today yet? 9. Let's make that a 9. Is that all right? So we'll make that a 9. We'll make that a 9. They don't tell you anything about the angles, but they do tell you it's an equilateral triangle. What do we know about all three angles of an equilateral triangle? Okay, they're all equal. Good. And they add up to 180. So how many degrees is each of these angles of that triangle? 60, right. 180 divided by 3. Make sense? So they didn't even tell you this was 60 degrees. But you should be able to figure that out if they tell you it's an equilateral triangle. Now, what about up here? If I take this, we had a theorem that talked about this. I'm not going to get into it. But if you have this and it's perpendicular, what do you think it does to this angle right up here? It cuts it in half. It bisects it. So what's this little skinny angle right here going to be then? That's going to be 30 degrees. That's right. Because that whole big angle right here was 60. Split it in half, that's 30. So check it out. We have a, what kind of a triangle? A 30, 60, 90 triangle. Very good. We got a 30, 60, 90 triangle. And what do we know about the 30, 60, 90 triangle? I tell you what, let's make this a little easier. Instead of making it 9, I should have thought about that. Let's make it a 10, just to make it easier for us, okay? So what I want you to do is I want you to find the length, that length right here, that red one, okay? Everybody see that? So which one is that? Is that the hypotenuse? Is it the shorter one? Is it the longer one? It's the what? There's a red one? On this right triangle. See this right triangle right here? Yeah, it's long because it's opposite the 60 degrees. Everybody got that? This one down here would be the shorter one. So which one can we find very, very easily? The shorter one. So if the hypotenuse is 10, what's the shorter one? It's 5. Okay, it's half. Would you agree? Now, how do I find the longer side? If I know the shorter side, look in your notes if you need to. It's the square root of 3 times the short side. That's right. So this long side right here, that red one right there, is just 5, what? Times the square root of 3. It's as easy as that. So if they give you the hypotenuse, it's not that hard. You find the short one by taking half of it, and you find the longer one by taking the short side, multiplying it by the square root of 3, and you got all the sides. And that's how you would do it. Make sense? Yeah, I think that's it. So let's do some homework. Did I assign anything on Friday? Was it 1 through 16? Were they all 45, 45? What did I assign? Oh, that's right. Right. Okay. Let me just finish this. Let's see. 1, 2, 3, 7, and 8, right? So that was 1, 2, 3, 7, and 8. That was section what? 7.4a. So today is section 7.4 what? B. And you are doing, let me look at my notes, 4, 5, 6, 9, 10. 4, 5, 6. That's supposed to be a 6, 9, and 10. All right, so what we're going to do is this. Everybody listening? If you have 7.4a right now, just hang on to it. Okay, I'm going to collect them tomorrow both. All right? And then so tonight, I want you to do 7.4b. I believe I mixed them up like this because these are all 45, 45, 90, right? Oh, was it? Oh, I tried to pick them. Well, yeah, number 4 is 30, 60, so right there. So these right here should all be 30, 60, 90s. I tried to split them up like this, so you only do the 45s one night, you only do the 30, 60, 90s the other night, okay? Just to keep it all straight. So these should all be 30, 60, 90 triangles right here. So basically, this ends up being 1 through 10, all right? I split them up, though, because these are all 45s. These are all 30, 60s, okay? And I just think it would be better that way. So have both of these finished for tomorrow. Tomorrow, I'm going to give you a worksheet. Let me look at my notes again. Yep. No, I just said it. I said tomorrow I'm going to collect both of them. But, yeah, well, you need to. So tomorrow I'm going to give a worksheet. And it's going to be both of these. It's going to be 45, 45, and 30, 60. What? The worksheet? On what? The Pythagorean theorem? I might have one. Let me see.